Hello everyone. Alright, let's go over the problem set number 6. Right, and question number 1. Calculate the expected return for a portfolio that has 3 stock. Okay, so your portfolio has 3 stock A, B, and C, and the return for A is 10%, for B is 12%, and for C is 18%. And the weight, okay, how many percent of the portfolio, which is the weight. Okay, so you have 20% of the portfolio is stock A and 30% is stock B, and 50% is stock C. Okay, so basically the return of the portfolio is a weighted average. Okay, you multiply the weight with the return of individual stock and you sum them up. Okay, so 20%, which is 20%, which is the weight of A times 10% plus 30%, which is the weight of B times 12, which is the return of B, plus 18 times 0.5, which is the weight of C, and equal to 14.6. Okay, now number 2, for the efficient portfolio. Alright, so let me go over what is the efficient portfolio. Efficient portfolios are the portfolios that satisfy the following 2 criteria. One is it offers you the maximum return for a given risk or standard deviation, at a given level of standard deviation, or the lowest risk. Lowest risk meaning lowest standard deviation. Lowest standard deviation at a given return. So either if a portfolio that gives investors the highest return at a given risk or given standard deviation, it is an efficient portfolio, or a portfolio that could give investor lowest standard deviation or lowest risk at a given return. Alright, so what is the answer over here is at the same, which is D, at the same expected return, the efficient portfolio is a portfolio that offers lowest risk. Meaning there's no other portfolio offers lower risk. Alright, number 3, which one is the most correct concerning 2 stock portfolio? Now if your portfolio has only 2 stock, alright, you have stock number 1 and stock number 2. And the return is year 1, year 2, alright. Standard deviation is sigma 1, sigma 2, and the weight you invest in each one of them is weight 1 and weight 2. And the correlation between the 2 stock is 1 and 2. In general, let me use a pen here so to make it more clear. Alright, so if you have a portfolio that has 2 stock, alright, first of all, the portfolio should have no company specific risk. Now 2 stock is not enough to diversify the portfolio. So if the portfolio is not diversified, then the portfolio will still have company specific risk. So obviously A is not correct. So obviously A is not correct. If you have only 2 stock in the portfolio, and the portfolio should still have company specific risk. And second, portfolio standard deviation can never be weighted average of the 2 stock standard deviation. And now let's take a look. If you have only 2 stock in the portfolio, the standard deviation of the portfolio always smaller than or equal the weighted average W1 sigma 1 plus W2 sigma 2. What it means is when you combine the 2 stock in the portfolio, the risk of the portfolio, okay, would be smaller than the sum of the risk of the choose stock. Okay, the reason the standard deviation of the portfolio is smaller because the correlation, okay, as long as the correlation, okay, the correlation, okay, which is relationship between the choose stock is smaller than 1, the standard deviation of the portfolio always smaller than the weighted average sigma 1 W1 sigma 1 plus W2 sigma 2. Okay, if the correlation is given, always given. All right, so correlation, if correlation is smaller than 1, then when you combine the two stock, you get a portfolio that will have that will have the standard deviation smaller than the sum of the two standard deviation. However, if the correlation, okay, if the correlation between the two stock is exactly equal to 1, okay, meaning the two stock are perfectly positively correlated, so that would mean, that there is no benefit of diversification. Okay, when you combine the two stock, the risk of the portfolio exactly equal to the average of the standard deviation W2 sigma 2. Okay, W1 sigma 1 plus W2 sigma 2 if you combine the two. All right. Okay, so the option B is saying that the portfolio standard deviation can never be weighted average of the two stock standard deviation. So this one is not true because they could be equal when the correlation equal to 1. So if the question says that it can never be equal, it is not true. It could be equal if the correlation is equal to 1. Okay, and whenever you combine the two stock, the return of the portfolio always equal to the weighted average W1 ER1 plus W2 ER2. Okay, so the return you get is the weighted average return, but the standard deviation you get always smaller than the weighted average standard deviation. Okay, the reason for that is because you are able to diversify the company's specific risk. Okay, if you're combining the two stock, you are able to diversify some of the company's specific risk, not all, but some of the company's specific risk. Okay, so obviously in question number 3, the correct answer is C. Okay, portfolio return is the weighted average of the two stock return. Now number 4, okay, the maximum benefit of diversification can be achieved by combining securities in a portfolio where correlation between securities is okay. Now remember the formula, the standard or the variance of the portfolio is weight 1 sigma 1 square, okay, plus weight 2 sigma 2 square plus 2 weight 1 sigma 1, okay, weight 2 sigma 2 times the correlation between 1 and 2. Okay, now so obviously if you look at this formula, you can see that if correlation between 1 and 2 is high, the standard deviation of the portfolio will be high. If correlation between 1 and 2 is low, the standard deviation of the portfolio will be low. Okay, so if you want to lower the standard deviation of the portfolio, you want to choose the correlation between 1 and 2. You want to choose the correlation is lower. How low can it get? Correlation between 1 and 2, okay, is from taking the values between -1, okay, to +1. So the lower the better. If you want to lower the risk for your portfolio, you choose stock that have lower correlation, and the lowest correlation can get is -1. Okay, so at -1 over here, you will have you have maximum benefit of diversification. Okay. Now number 5, portfolio is composed of two stock A and B. Okay, And so basically using the same formula in number 4, I just wrote it here. Okay, you calculate the W1, which is stock A 40%, which is weight 1, so 0.4 times standard deviation of stock A, which is 20% of 0.2, so 0.4 square times 0.2 square plus 0.6, which is the weight of stock B square, times 0.3, which is the standard deviation of stock B square, plus 2 times, okay, see that, weight 1, which is 0.4, weight 2, which is 0.6, sigma 1, which is 0.2, sigma 2, which is 0.3, times the correlation, which is 0.5. Okay, and you get the variance is 0.0532. You take the square root, you get the standard deviation is 23.1%. Okay, now so you have two stock A and B. Okay, and okay, have two stock A and B. So if A has returned 10%, okay, 10% return, and B has returned 18%. What is the proportion in A? So in the portfolio, so that expected return is of the portfolio is 16.4. So if you put weight A is WA, you have only two stocks, so weight in B would be 1 minus WA. Okay, so the return of the portfolio is 16.4. 16.4 basically is weighted average return. So it is equal to weight 10%. All right. You can use decimal like we have in here, or you can use percentage. It should be the same thing. So equal to 10% times weight A, okay, plus for B, which is 18% times 1 minus, okay, weight A. Alright, you solve for weight A, you get weight A is 20%. Okay, now number 7, which of the following portfolios cannot lie on the efficient frontier? Now, if any portfolio is on efficient frontier, that would be efficient portfolios. And the efficient portfolios are the portfolios that give investor highest return at a given standard deviation or lowest standard deviation at a given return. So if you look at portfolio Y and Z, they have the same standard deviation, which is 25%. And Z obviously give investor more return than Y, so obviously portfolio Z is better than portfolio Y. Okay, so you can tell right away that portfolio Y cannot be on the frontier because portfolio Y is worse than portfolio Z. Okay, portfolio Z is better than portfolio Y at the same 25% standard deviation. So for that reason, portfolio Y cannot be on the efficient frontier. Now number number 8, the correlation. Remember, the covariance is equal to the correlation times between the two stock 1 and 2 times sigma 1 times sigma 2, and covariance tell you about the direction between the two stock. Correlation tells you how strongly or how weakly they are correlated to each other. So if you know correlation, you should be able to calculate covariance, and vice versa. If you know covariance, you should be able to calculate correlation, which is equal to covariance divided by sigma 1 times sigma 2, and covariance is equal to 0.06, okay, divided by sigma 1, which is 0.25, times sigma 2, which is 0.3, and this is equal to 0.8. Okay, so the correlation between the two stock A and B is 80%, which is very high. Okay, correlation can be as high as 1 and can be as low as -1. Number 9, if you choose a stock from different industry, you can eliminate the basically non-systematic risk. Okay, let me go review a little bit about the risk. You have total risk. Total risk has two types of risk. One is the market, okay, which is the uncertainty at the market level. The other one, which is the uncertainty at the firm level, which is the specific. okay, firm specific risk, and the market risk, okay, because it affects the entire market, it is systematic, okay, it is systematic. And the other one, it doesn't affect the entire market, it affects only individual firms, so therefore it is unsystematic, okay, it is unsystematic risk. And when you combine many stock from different industries in a portfolio, you are able to diversify the risk over here, so therefore it is diversifiable, okay, it is diversifiable risk. And for this one, it is no matter how many stock you have in your portfolio, you are not able to diversify away the market risk, so therefore it is non-diversifiable, okay, it is non-diversifiable. It is a risk that the investor will always have in the market. So obviously if you choose many stock from different industries, you are able to eliminate the non-systematic, which is the specific risk over here. Alright, number 10, a positive covariance, indicating the two stock tend to move in the same direction. Okay. Number 11, when you add more stock in a portfolio, obviously you are able to diversify away the firm's specific risk. All right. So if you are able to lower the firm's specific risk, okay, the total risk would be lower as well. So both B and C are correct. Unsystematic risk would decline, and at the same time total risk would decline as well. And number 12, all right, okay, question 1, and diversifiable risk can be eliminated by investing in several unrelated securities, which is correct. Okay, you can diversify it away. The market rewards investor for diversifiable risk. No, the market doesn't reward investor for diversifiable risk, because investor can diversify it away. So this is not correct. Okay, so now we go back to the one we had before, because this risk can be diversified away, so it is irrelevant risk. Okay, it is irrelevant because investor don't earn return for the specific risk, because it can be diversified away. But for the market risk, because no matter how many stock you have in your portfolio, no matter how you diversify your portfolio, you cannot eliminate the market risk. Okay, so therefore this is a risk you will have no matter what, so it is relevant. And if it's relevant, you have to earn return. Okay, when you earn, you have to be compensated for that. You have to compensate for the relevant risk, so which is a return. So what it means is, go back here, the market will not reward investor for the diversifiable. The market reward investor only for the market risk. Okay, so 2 is not correct. Diversifiable risk related to firm or industry, which is correct. Beta measure diversifiable risk. No. Okay, beta is a measure for market risk. Okay, market risk is measured by beta. Alright, so obviously over here number 1 and 3 are correct, so it is A. Alright, number 13, okay, similar. You have non-diversifiable risk is measured by standard deviation. No. Okay, standard deviation measure the total risk. Alright, total risk measured by standard deviation. Systematic risk is another name for non-diversifiable, which is true. If non-diversifiable increases, the risk premium would increase. Okay, which is true, because that is the only risk you have. If the risk is higher, the premium has to be higher. Non-diversifiable risk are the one you cannot avoid. Okay, which is true. So you have 2, 3, and 4. So D is correct. Alright. Number 14, which one is okay? Number 14, which one is an example of non-diversifiable risk? Okay, which is anything related to the market. Alright, so anything affects the entire market, which is the Federal Reserve. Number 15, which one is relevant to a well-diversified investor. Okay, well-diversified investor, you have systematic, you have market, you have non-diversifiable. So they are all the same thing. Unsystematic can be diversified away. Alright, so what it means is you're looking at 1, 3 and 4. Okay, number 16, which one is an example of systematic? Obviously the Federal Reserve, because it's related to the market. Number 17, which one is an example of unsystematic risk? Okay, which one is not systematic? Obviously interest rate is a systematic, federal government is systematic, interest rate is systematic, GDP is systematic. So the only thing left which is not systematic is C. Okay, number 18, which one of the following actions will help eliminate unsystematic risk in a portfolio? If you combine, okay, stock, combine, if you spread retail industry portion of a portfolio over 5 stock, okay, different stock, that would help to eliminate the unsystematic risk. Combine stock with bond, which is true. Adding some international securities, which is true. Adding some T-bill, okay, which is true. So everything is correct. So answer is A. Number 19, expected return. Simple. Can you expect the return of the portfolio is weighted average return. So multiply the return of A with the weight of A, which is 18 times 0.7 plus 12 times 0.3 equal to 16.2. Number 20, okay, suppose that A and B are perfectly negatively correlated. So if the correlation between A and B equal to -1, okay, the standard deviation of the portfolio would be equal with A times sigma A minus with B times sigma B. Okay, and this has to be equal to 0. So you solve for with A. Okay, so let with A is basically let with A is equal to so you can see from here with A, sigma A, okay, you equal to with B times sigma B. So right, so you can have with A over with B equal to sigma B over sigma A, and sigma B, which is equal 30% over sigma A, which is 20%, equal to 1.5. So you have with A is 1.5 times with B, and you know that with A plus with B equal to 1, okay, because you have only two stock in the portfolio. So you solve the equation. Alright, you solve the equation, you should be able to get with A equal to about 60% and with B equal to 40%. Alright. Number 21, portfolio diversification exists only when, okay, as long as the correlation between 1 and 2 is smaller than 1, the standard deviation of the portfolio will be less than the the weighted average standard deviation, because you are able to eliminate some of the firm's specific risk. Okay, so if it's smaller than 1, the standard deviation of the portfolio is smaller than the average standard deviation. So what it means is you have benefit. Alright, you have benefit of diversification. Okay, as long as it's smaller than 1 correlation. The only time you don't have any benefit is when correlation is exactly equal to 1. So Paul invested in the project that has 80% doubling. Okay, so the probability is 80% when the return doubling, meaning it's 100. It is 100%. Okay, double your investment, so 100%. 20%, the return is it's cut by half, so the return is equal to -50%. If it's cut by half, it is -50%. So you should be easily get the expected return, which is 0.8 times 100 plus 0.2 times -50 equal to 70. and then you calculate the variance and the standard deviation, you get about 60%. Okay. Number 23, I believe we went similar to the previous question. Portfolio Y and Z have the same standard deviation, but obviously Z offer better return than Y, so Y cannot be on the frontier. Okay. Now number 24, Matthew has 800. Now Matthew new portfolio. Okay, you have $1 million in the new portfolio, which has $800,000 in the previous portfolio or portfolio, and the $200,000 okay on the stock XYZ. All right, so obviously the weight how many percent in here for the old portfolio in the new portfolio, which is 80%. So in this new portfolio, 80% would be the previous portfolio and 20% would be the weight of stock XYZ. Alright, so the originally the standard deviation of this old portfolio is 148%, and the standard deviation of XYZ is standard deviation of the original is 119. Okay, it is 119%, and the XYZ so standard deviation is 148. Okay, and the correlation between the two is equal to 20% correlation. Okay, so the variance of the new portfolio now, okay, equal to weight 1, which is 0.8, times 1.19, okay, the whole thing square, alright, plus weight 2, which is 0.2, times the standard deviation 148 square, times 2 times 0.8 times 119 times 0.2 times 148 times the correlation between the two, which is 0.2. So you get it is equal to the answer right here. Take the square root, you get the standard deviation. Okay. Number 25, similar. Now number 26. Very similar. Okay, you have the old portfolio, you have the new portfolio that has the old portfolio, okay, and the stock ABC. So old portfolio you have 900,000, the new portfolio you have $1 million. Okay, $1 million, out of that, out of 1 million would be 900,000, and ABC is 100,000. So this would give you 90%, this would give you 10%. Okay, so expected return of the new portfolio, which is expected return of the new portfolio would be equal to 0.9 times the return of original, which is 0.67, plus 10% of the stock ABC times the return of ABC, which is 125, and this is equal to 0.728%. And the covariance, you know that the covariance equal to correlation times sigma 1, okay, times sigma 2. So correlation is equal to 40%, sigma 1 237, sigma 2 295, and covariance is 2.8. Alright, the standard deviation of the new portfolio, okay, use the formula we have in here, and you should be able to get the standard deviation. Number 27, assume that you replace the stock ABC with the government security, which is risk-free rate. Okay, so the new portfolio now will have the original portfolio, which is the old portfolio, $900,000, which is 90%, 0.9, and this, now it is the government, okay, security, which is, for example, T-bill, 10%. Okay, so the expected return now would be equal to 0.9 times the return of the portfolio, 0.67. All right, the previous portfolio, plus 10% in T-bill, and the return of T-bill is 42%, 0.42%. So 0.1 times 0.42 equal to 0.645. And the covariance equal to correlation times sigma 1, sigma 2. But remember the standard deviation of the T-bill is 0. So the whole thing is equal to 0. And the correlation is also equal to 0. correlation between the government security and any other security is 0. And the standard deviation, you use the same formula we had before. Okay, so you have, all right, you have the variance of the new portfolio. Okay, variance of the new portfolio will be equal 0.9 times, okay, standard deviation of the previous portfolio 237, okay, square time sigma w2 0.1 times sigma 2, which is 0, okay, square plus 2 times width 1, 2 times 0.9 times 237 times width 2, which is 0.1 times sigma 2 0 times correlation 0. All right, so you take the square root, you get about 2.13%. All right, number 28. All right, so currently you have $2 million invested. All right, you have $2 million invested in this, in short-term bonds, in large cap, domestic caps. Okay, and so the return of your portfolio right now is about 13.8%, and the standard deviation is 23.1. So you have two objectives over here: maintain or enhance your return. All right, so you want to have at least 13.8%, and at the same time maintain or reduce the volatility. So you want the standard deviation to be smaller than 23.1. Okay, so you're considering one of these 4 index fund to combine with your current portfolio. Alright, so which one is the best? Now take a look at fund A. If you combine fund A with your portfolio, okay, the return of fund A is 15%. Alright, so which is higher than the current return you have, which is good, but at the same time the standard deviation of A is pretty high, 25%. Alright, which is more than 23.1. So yes, it is satisfy the first requirement, but it doesn't satisfy the second requirement. So A is not good. Alright, A is not good. Look at B. B has returned 11%. So 11% combined with 13.8 obviously will give you a new portfolio that has a return lower than 13.8, which is not what you are looking for, because you need to maintain or enhance return. Alright, so B is not good. C, 16% return combined with 13.8, which is good. Alright, but at the same time the standard deviation 25% combined with 23.1 will give you a portfolio that has standard deviation higher than 23.1. Alright, so obviously C is not good. Now finally you have D, 14 combined with 13.8, so you have a portfolio that will have return better than 13.8. Standard deviation 22 combined with 23.1 will give you a portfolio that has standard deviation smaller than 23. Okay, so D is a good thing. Alright, D satisfies the both requirements: maintain or enhance your return and reduce your volatility. Okay, so your recommendation is to choose fund D to combine with your portfolio. And finally, number 29. Okay, all right, so it's a little long, but I just want to answer it briefly. So basically this, all right, Hennessy wants to limit the number of stock. Right now, the portfolio currently has about 40 to 50 stock. Okay, and Hennessy believes that he's very good at picking stock, so he want to limit to 20. Now, so limitation of 20 stock will increase or decrease the risk of the portfolio. So obviously the lower number of stock you have will increase the risk of the portfolio, because you will have more specific risk. Okay, you will have more specific risk. The more number of stock you have, the lower firm's specific risk. So if you have only 20 stock, that would likely increase the risk of the portfolio. Now B, Is any way Hennessy could reduce the number of stock from 40 to 20 without affecting the risk? The answer is yes. Okay, if Hennessy could choose the 20 stock, okay, the 20 stock that Hennessy choose over here need to have very low correlation. Okay, because we study before, or what we study is a lower correlation the better, because lower correlation, lower risk. Okay, low correlation, lower risk. Yes, so, okay, so if you are able to manage to choose 20 stock that have very low correlation, how low can you get? The lower you can get to -1, the better for the portfolio. So if you are able to choose a stock that have very low correlation, you should be able to lower the risk of the portfolio even if you have only 20 stock. Okay, so it's very important that when you diversify the portfolio, you choose a stock that have low correlation or negative correlation. All right. Okay, so that's pretty much about the problem set number 6. Any question, let me know. Okay, thank you. Bye bye.